Hello everyone. In today's lecture, we're gonna keep talking about classifiers, which is an important class of tools for machine learning. Specifically, we're gonna talk about first we talk about the first linear classifier. And we're gonna give you an introduction about the presection. Again, so let's introduce what's the assumption do we have? We have a sample of n observations. So so first we need some data. So a sample of n observations. And in our class, this letter n always represents sample size. And each feature has d features. Okay, so for example, so d is usually denotes the number of the inputs in our class, and some observations belongs to class C. So let's talk about the binary classification first. So class C. Some of the observations belongs to class C, some not, some do not. So here is one example. We have let's keep using the example we talked about in our last class. Suppose you work in a bank, and you are the loaners. So you need to decide which customer we approve their loans, which one we do not approve their loans. Okay, and the features here are we considered here could be like in this following example, we consider two features only. So features d equals to 2. One feature is age. Okay, another feature is income. And some of the individuals are classified as defaulted. Some applicants. Defaulted. So here, for example, in the following scatter plot, we have the few scenarios, are fake data. So this scatter plot about applicants' income and age, and this red circle represents the defaulted one. So which means they didn't pay back their loans on time. And the blue ones are reliable ones. Okay. So and some of them are reliable. And the goal here is predict a future borrower borrower will default given age, given the new applicant's age and income. Okay. So for example, suppose we have three different scenarios. The first scenario, we have the scatter plot with reliable loaners and borrowers and the default borrowers. Seems they are very easily to be separated by a line. Okay, we call this is a decision boundary. Okay. For the second case, seems we cannot just using a simple line to separate them, but with some techniques, we can somehow using this V-shaped curve to separate them. The last scenario is more complicated. You cannot even by using the combination of the lines to separate them. We need more complicated decision boundaries to separate the default ones and the good ones. So there is a basic concept, what is called decision boundary. So a classifier, the goal is to find a decision boundary. That is chosen by classifier. To separate items in class. From those not. Okay, so that's the decision boundary. Actually, another concept we talked about in the last class is about overfitting. You're gonna keep hearing about overfitting and underfitting along the classes. So, what's the meaning of the overfitting? Which of the scenario we just showed you is overfitting? Actually, the overfitting happens when decision boundary fits the sample points so well. Too well. That it doesn't classify future points. For example, the last case, in our previous example, we see the decision boundary curved around between the default ones and the reliable ones. So it works perfectly on the training data set, but actually this is not a good sign. That if we have the future data, okay, if we have future data, it may not work very well for the future data. So that means overfitting. Okay, so next, a lot of cases, the decision boundary is determined by a function called decision function. Decision function is a function fx. The input is the features that maps features vector x to a scalar. Such that, so st means such that if the decision function gives a positive value, if x belongs to class C, if fx is below than 0, if x does not belong to C. So actually it won't matter where this boundary point is. You can, it usually does won't matter much if you put an equal sign top or bottom. Okay. So this is called decision functions. And then decision boundary we can define mathematically. So decision boundary can be defined by the set of points such that this decision function is equals to 0. For example, later on for the linear classifier case, we're gonna define the linear classifier function, decision function, and we're gonna you're gonna see that the decision boundary is just that line equal to 0. Okay. Sometimes this quantity is also called isosurface of decision function f for iso value 0. Okay. For example, a decision function could have other isosurface. For example, isosurface at 1, isosurface at 2. Actually, we can have the isosurface here. Let me put more graphs here. Okay, actually suppose we have a data set with 2 features. This, you can think this is x1. This direction is x1. This direction is x2. Okay, and this is supposed to be your decision function fx. And on the right hand side, it shows the isosurface for this decision function f. So which means at each this circle, so this is a special function. So this isosurface for f is just circles. For example, we can find a circle such that this fx is equals to 0. and every points inside this decision boundary has negative value. Outside this decision function has positive values. So in this case, so this is our decision boundary. Okay, and actually this function is just a very simple function. F x1 x2 equals to square root x1 square plus x2 square minus 3. Okay, so this is called isosurface, also called isosurface. Of f for iso value 0. Okay, so here we introduce some new terminology.